Selamat pagi rekan-rekan mahasiswa. Hari ini kita akan belajar bersama mempelajari IPv6 Neighbor Discovery. Dalam materi ini, Anda akan mempelajari operasi Neighbor Discovery, menjelaskan bagaimana IPv6 Neighbor Discovery bekerja.
In this video, we will discuss the process of how IPv6 performs address resolution using ICMP-v6 neighbor solicitation and neighbor advertisement messages. This is similar to the ARP process used by IPv4, but has certain advantages that we will see in a moment. Host A has a packet to send to host C. Host A has determined that the destination IPv6 address is on the same network as host A. Host A knows the destination IPv6 address, but needs the associated destination MAC address so it can encapsulate the IPv6 packet in an Ethernet frame to send directly to host C. Host A examines its neighbor cache to see if there is an entry for this destination IPv6 address. Similar to an ARP table, the neighbor cache maps IPv6 addresses to MAC addresses. For simplicity's sake, MAC addresses are shown here as 4 hex symbols instead of the usual 12. As we can see, there is no MAC entry associated with this IPv6 address. The IPv6 packet is placed on hold, and host A creates an ICMP-v6 neighbor solicitation message. This is similar to an ARP request used for IPv4 address resolution. One significant difference is that ARP messages are sent directly over Ethernet. IPv4 is not involved. The IPv6 address resolution process uses ICMP-v6, which is then encapsulated in an IPv6 header and then encapsulated in an Ethernet header and trailer. The ICMP-v6 neighbor solicitation header includes the target IPv6 address, which is the same destination IPv6 address in the packet that is on hold. The target IPv6 address is mapped to a special IPv6 solicited node multicast address, which is then mapped to a special Ethernet multicast MAC address. This mapping process contains a significant portion of the target IPv6 address. This allows for the Ethernet NICs on each device that receives this frame to determine whether or not to accept and process the frame. This is where we see an advantage of ICMP-v6 neighbor discovery over ARP for IPv4. Since ARP uses an Ethernet broadcast address, all devices on the local network must at least partially process an ARP request. The ICMP-v6 neighbor solicitation message is forwarded by host A and received by the switch. The switch will flood the Ethernet multicast frame out all ports except the incoming port. Host B receives the Ethernet frame. Host B's Ethernet NIC examines the destination MAC address. The Ethernet NIC will accept frames whose destination MAC address matches the MAC address on the NIC, is a broadcast MAC address, or a multicast MAC address that maps to one of its IPv6 addresses. In this case, the multicast MAC address does not match any of these, so host B's NIC ignores the rest of the frame, without having to pass it up to an upper-level process to make this determination. Again, this is an advantage over ARP for IPv4. Router R1 receives the frame on its LAN interface. A similar process occurs on R1's interface. The Ethernet NIC ignores the frame because the destination multicast MAC address does not map to any of its IPv6 addresses. ICMP-v6 neighbor solicitation messages are not forwarded by the router. This is because the solicited node multicast address in the IPv6 header is sent with link local scope, which tells the router not to forward these packets off the local linker network. Host C receives the Ethernet frame. This time, the Ethernet multicast MAC address matches a MAC address associated with host C, specifically the one mapped to host C's IPv6 solicited node multicast address. Therefore, host C accepts the frame and passes it up to its IPv6 process and then its ICMP-v6 process. The target IPv6 address in the ICMP-v6 header matches its own IPv6 global unicast address, so host C knows it is the target of this neighbor solicitation message. Before replying, Host C adds the IPv6 and MAC address of host A to its own neighbor cache, so it can return a neighbor advertisement message. Host C replies with an ICMPv6 neighbor advertisement message sent as an Ethernet unicast message directly to host A. The ICMPv6 header includes host C's IPv6 address, which host A already knew, and the associated MAC address that host A was requesting. Host A receives the Ethernet frame, examines the IPv6 address and the MAC address in the ICMPv6 header, and adds it to its neighbor cache. Host A can now take the IPv6 packet off hold. Host A updates the destination MAC address with the address associated with the destination IPv6 address and forwards the frame and IPv6 packet to host C. Note that if the destination IPv6 address was on a different network, this same process would occur to discover the MAC address of the default gateway, which would map to R1's IPv6 link local address on this LAN.
Protokol IPv6-ND, juga disebut NDP, menyediakan layanan resolusi alamat, penemuan router, dan pengalihan menggunakan ICMPv6. ND menggunakan 5 jenis pesan ICMPv6. 1. Neighbor Solicitation. 2. Neighbor Advertisement. 3. Router Solicitation. 4. Router Advertisement. 5. Redirect Message. Pesan Neighbor Solicitation dan Neighbor Advertisement digunakan untuk komunikasi antar perangkat dalam resolusi alamat, mirip ARP di IPv4. Sementara itu, Router Solicitation dan Router Advertisement digunakan untuk komunikasi antara perangkat dan router, seperti alokasi alamat dinamis dan Stateless Address Auto-Configuration, SLAAC. Redirect Message digunakan untuk pemilihan jalur terbaik. IPv6-ND didefinisikan dalam IETF-RFC 4861. Seperti ARP pada IPv4, IPv6-ND digunakan untuk menentukan alamat MAC dari perangkat dengan alamat IPv6 tertentu. Pesan ICMPv6 Neighbor Solicitation dan Neighbor Advertisement digunakan untuk resolusi alamat MAC, mirip dengan ARP Request dan ARP Reply pada IPv4. Misalnya, jika PC1 ingin melakukan ping ke PC2 dengan alamat IPv6 2001 DB8 ACAT 11, PC1 akan mengirim pesan ICMPv6 Neighbor Solicitation menggunakan alamat multicast khusus. PC2 kemudian merespons dengan Neighbor Advertisement yang berisi alamat MAC-nya. Kesimpulan untuk materi hari ini. IPv6 tidak menggunakan ARP, melainkan menggunakan Neighbor Discovery atau ND untuk menyelesaikan alamat MAC. ND menyediakan layanan resolusi alamat, penemuan router, dan pengalihan untuk IPv6 menggunakan ICMPv6. ND menggunakan 5 pesan ICMPv6. 1. Neighbor Solicitation. 2. Neighbor Advertisement. 3. Router Solicitation. 4. Router Advertisement. 5. Redirect. Seperti ARP pada IPv4, IPv6-ND digunakan untuk menemukan alamat MAC berdasarkan alamat IPv6 yang diketahui. Sekian penjelasan materi hari ini, terima kasih dan jangan lupa like, comment, and subscribe untuk mendapatkan materi terbaru dari kami.